Hello students, today we are going to start with the mock test series. Whoever registered to our class, they got to solve the mock test papers, like 30 mock test papers. They have started it long back. Now we are going to do the analysis of those mock tests. What you can expect from this analysis is that you can download the question paper. I am attaching the PDF link. Okay. You can download the question paper. This is mock test 2. Download the question paper and try to solve it in 30 to 45 minutes, not more than that. If you are able to solve all 30 questions in 30 to 45 minutes, definitely you can do good in your examination. Okay, so today we are going to make a challenge. We are going to solve it in 30 to 45 minutes. Okay, not more than that. Let's see. Let's start with this question. Which of the following salts will not undergo hydrolysis in aqueous solution? This type of question is asked from separation, equilibrium, right? So hydrolysis occurs when either of the cation or anion of the salts reacts with water to produce acid or basic solution. Okay, cool. So let's start with the NH4Cl. That will give you ammonia and H3O plus. What about sodium carbonate? Again, that will give you upon hydrolysis OH minus salts, particularly NaOH and bicarbonate also. Bicarbonate salt also. What about this guy NaCl? Na comes from a strong base, NaOH, and Cl comes from the strong acid HCl. Neither ion hydrolysis. So answer to this question becomes NaCl. What about sodium acetate? Once again, I am telling you, acetic acid and NaOH is formed. So which can undergo hydrolysis in aqueous solution? To answer to this question is NaCl. Let's move on to the second question. The IUPAC name of the compound: CH3CHOH CH2 CH3 CHO. So asking IUPAC name. First thing first, you have to go about the preference order, priority order of the functional group, which will get, of course, our aldehyde group. Okay, so aldehyde group, apart from the substituents, how many carbons are there? This is substituent. So 1, 2, 3, 4 carbons are there, including aldehyde group, total 5 carbons. So aldehyde end with pentanal. Correct. Okay. So substituent and OH group, which will get more priority? Of course, alcohol group, right? So it should get a lowest localent, lowest numbering. So 2-hydroxy pentanal and then 4-methyl. So 4-methyl 2-hydroxy pentanal becomes the right answer to this question. So according to the alphabetical order, it makes it 2-hydroxy 4-methyl pentanal. The complex of, we already saw that A4B2 type, right? MA4B2 type exhibit which type of isomerism? Yes, it can exhibit, this is an octahedral, isn't it? So this can exhibit geometrical isomerism, cis and trans. Cis means the groups are B, which will be on the same side, and trans, which becomes the opposite side. Out of these, cis and trans, cis can form a non-superimposable mirror images. So it can exhibit optical isomerism. We talked about lot in isomerism in coordination chemistry crash course. So please do check it out if you are not aware of that. And what about trans? Trans will not exhibit optical isomerism because it will have plane of symmetry. So answer to this question is both geometrical and optical. I have given you the list who all can exhibit optical, who all can exhibit geometrical and more. Then this question, which of the following statements is incorrect about the hydrogen bonding? It leads to association of molecules. It exists between molecules having fluorine, oxygen and nitrogen atoms. It is stronger than covalent bonding. It affects the boiling point of the compounds. See, first of all, let's examine these statements. Hydrogen bonding does lead to association of molecules, causing liquids like water and to have a cohesive properties, right? And what about the second option? It exists between molecules having fluorine, oxygen, nitrogen. Why? These are more electronegative. So electronegative to the hydrogen than the hydrogen. So which makes it more polar and the bond formation will be more for the hydrogen bonding. So that is also true. It is stronger than covalent bonding. Is it true? Hydrogen bondings are intermolecular forces that are much weaker than the covalent bonds. Covalent bonds will have a strength around 200 to 800 kilojoule per mole. But in case of hydrogen bonds, that just require 5 to 30 kilojoule per mole to break the bond. So it is definitely not a correct statement. So which makes this as a correct answer? What about the option 4? It affects the boiling points of compounds. Yes, it's true, because it makes the bond stronger and boiling point is something but the breakage, right? So which makes the boiling point, increases the boiling point of the compound. So answer to this question is option 3. In this question, the correct order of acidic strength. Here we have oxo acids. The acidic strength of oxo acids depend on the number of oxygen atoms. Why, ma'am? Why it's depend on the oxygen atom? Also, it depend on the electronegativity. I'll tell you why. With more number of oxygen atoms, which makes OH bond weaker. So that what will happen? It will lead to release, more easily release of H plus ions, right? So oxo acids of the same central atom, like here we have Cl. The acidic strength increases with increase in number of oxygen atoms. Increase in number of oxygen atom. Okay. So let me give you the answer. What is the answer? I'm sure you might have guessed. 4, 3, 2, 1. So which makes option 2 is the right answer to this question. Then the rate of the first order reaction doubles when the temperature changes from 300 to 310 Kelvin. The activation energy of the reaction is Arrhenius equation, isn't it? See, the temperature changes 10 degrees. So of course, Arrhenius equation you have to remember. What it says, ln K2 by K1 equal to EA by R 1 by T1 minus 1 by T2. Sometimes we'll try to get T2 minus T1 by T1, T2 also. So let's substitute the values. So ln, what they are saying, the reaction doubles. The rate of the reaction doubles. So overall, we are taking that as 2 equal to EA by R. Just substitute the values. 1 by 300 minus 1 by 310. Ln 2 value we very well know about from half-life equation, right? 0.693. And then R value also you can substitute in the last one. They have given that 8.314. 310 minus 300 divided by 300 into 310. So just do it as a 310 into 3, which is nothing but 930. So which makes it 93000. So just we have to do the simple calculation to make it as, to find it out, EA. So EA becomes 0.693 into 8.314, and then remaining what we'll have 10 by, that makes it, can just cancel it out and just do the multiplication. So why I'm saying you have to finish it by 30 to 45 minutes, why I'm giving you 15 minutes extra for each of these questions, because of these calculations. Okay, you need not to get an accurate thing, you can do round off, because you can see the values are far away from each other. They are letting us to do the round off. Okay, so answer to this question is 54.6. Let's say this question, in the complex of iron cyanide, the oxidation state and the coordination number. Very, very, very simple question. By seeing the question itself, you can tell me the answer. Come on. Post it in the comment. Quick, quick, quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Time up. Only 10 seconds to solve this type of questions. Of course, iron oxidation state is +2. So either A or B. So what about the coordination number? It's 6. So simple, right? It will take only 10 seconds to answer this type of questions. And which of the following statements are not correct? Let me make this clear. The value of Henry's constant increases with increase in temperature, and molality of the solution remains unchanged with temperature. Osmotic pressure is a colligative property. Addition of non-volatile solute to a solvent decreases its vapor pressure. Okay, so which one is not correct? First one, the value of Henry's constant is related to solubility of gases in liquids, right? For most of the gases, solubility decreases with increase in temperature, correct? Which makes KH increases with temperature. Because the gaseous of which solutions are exothermic, so higher the temperature favors the undissolved state. So we have discussed everything in the crash course. So first option, that is true. Then molality is defined as, what is the molality? Molality, which is moles of solute per kilogram of solvent. Correct. So since the molality does not depend on the volume or the temperature, so absolutely molality will not change as the temperature changes. So which is an incorrect, sorry, they have given us unchanged. Okay, that is an incorrect statement. What about osmotic pressure is a colligative property? That is also true. And the last option, addition of non-volatile solute to the solvent decreases the vapor pressure, because the fewer solvent molecules are available at the surface to evaporate. Correct. So this is also correct, this is also correct, this is also correct. What about the first one? As I told you, Henry's constant increases, KH value increases with temperature. Let's say this question, hybridization of central atoms BrF5, SF4, XeF4 respectively. Okay. They're just asking, I think I have told you the trick to find out the hybridization. You do not to go about much details. You can just glue it with the valence electrons. I'm telling you for this, bromine and fluorine is there. Both of them are having the valence electrons as 7. So 7 plus 5 into 7 for fluorine. So 5 into 7. So which makes it 35 plus 7, 42. So if the value is 8 or more than 8, more than 8, just divide it by 8. Okay, if I'm dividing it by 8, what will I get? 5 as my answer. Still I'm having 2. Less than 8 divided by 2. So here I'm having 2. So I'm dividing it by 2. So total 5 plus 1, 6. So 6 you have to take it for the hybridization, and 5 is a bond pair, 1 is a lone pair. Everything is sorted out with this calculation. I'm doing it for you again. SF4. Okay, sulfur, which is having oxygen group, right? So 6 valence electrons plus 7 for fluorine. So 4 into 7. So total 4 7s are 28. 28 plus 6, 34 divided by 8. Then 4 plus 1. Remainder is 2. 2 is less than 8. So I am dividing it by 2. So 4 bond pairs, 1 lone pair, and 5 for hybridization. Similarly, you can do it for XeF4. Okay. So tell me, what is the hybridization for 6? Total electron pairs are 6. So sp3d2. Where I am having sp3d2 in 3 options. Okay. What about SF4? 5. So that is having sp3d. Okay. I am narrowing down to option 1 and 2. What about XeF4? XeF4 will have 4 plus 2, 6. So once again 6, which makes option A. When cyclohexanol is treated with the hot concentrated H2SO4, the major product formed is cyclohexanol with concentrated H2SO4. So the major product formed is. So what will happen? What is the duty of H2SO4? Dehydration, isn't it? So dehydration occurs. So alcohol lose a water molecule to form alkenes. So which of the product is our alkene? Cyclohexane, isn't it? So from here, water molecule will get escaped. The reaction of acetylene with H2SO4 and mercuric sulfate in the presence of water produces. What is this reaction? Oxymercuration, demercuration, isn't it? So acetylene with mercuric sulfate, H plus in the presence of water. So what will happen? Oxymercuration, demercuration. It adds, mercuric sulfate acts as a catalyst, and reaction proceeds to form a H on one side, OH on the another side, which makes it CH2CHOH, which is unstable. So it immediately tautomerizes to form CH3CHO, ethanol, right? So usually that will form alcohol. Okay, but the twist here is that it undergoes tautomerization. Which of the following contains both ionic and covalent bonds? Which one? By seeing question only you can answer this question. K, between potassium and Cn, I am having ionic bond, and between Cn, C, carbon, and nitrogen, they are having covalent bonds. Which of the following is biodegradable polymer? So which is polyglycolic acid. The other ones are PVC, polythene, nylon 6X, which is a memory based question. Then for the reaction of Haber's process of ammonia, the equilibrium constant Kc is related to the equilibrium constant Kp is. We know the simple equation Kp, which is equal to Kc RT power delta N. What is delta N? Number of moles of product minus reactant. So 2 minus 1 plus 3, 4 minus 2. So just substitute the values. Kp equal to Kc RT power minus 2. Sometimes they will give this as direct. Sometimes they will take this to the another side. So which makes the power to positive. Let's say this question, which of the following compounds will form racemic mixture during monobromination in the presence of light? For forming the racemic mixture, it should have a chiral center, right? So upon doing the monobromination, which can form a chiral center, let's see. So butane, 2-methylbutane. So if that is replacing this hydrogen, it will not make any chiral center because 2 CH3 groups are here. So what will it is replacing one of those hydrogens here. So it can make a chiral center. And 2,3 dimethylbutane. So in this case, if that is replacing this hydrogen, won't make sense because 2 CH3 groups already there on the same side. So this is not going to make any racemic mixture. What about option 3? 2-methylpropane. So if that is replacing this hydrogen, again it won't make any sense because 3 CH3 groups are already there. Then propane. Either this hydrogen or another hydrogen won't make any sense because already 2 CH3 groups are there. So answer to this question is 2-methylbutane. Let's say this question asking about find the pH of the buffer solution containing 0.2 molar acid and 0.3 molar of the salt. pKa is given. So quickly substitute it with the formula. The formula is pH is equal to pKa plus log of salt concentration by acid concentration. Come on, quick. So pH, pKa, that is 4.76, log of salt concentration, that is 0.3, acid, that is 0.2, 3 by 2. So the log of 3 by 2, which makes around 1.5, log 1.5, just around 0.1, right? Okay, so 0.1 I'm taking, which makes the answer 4.86. So is it any answer nearer to that? Definitely it is getting increased, so not will be, it is the answer won't be 4.76. It's more than that. So 4.94 would be the right answer. The compound formed when the benzaldehyde reacts with concentrated KOH. Benzaldehyde reacts with KOH. So what are the products will be formed? So what is this reaction is about? This none other than our favorite Cannizzaro reaction. Cannizzaro is nothing but disproportionation reaction. So aldehyde will form alcohol as well as acid. So which of the following is the right answer? So they didn't mention about acid, so take it as a salt. So where is alcohol? Option A, we have potassium benzoate and benzyl alcohol. Yes, that makes it a right answer. Very rapid and easy stuff. Major product of the following reaction: CH3, CH2, CH2Br with ammonia. So what that will form? When alkyl halide reacts with excess ammonia, The major product is amines, right? So what kind of amine? Primary amine. We talked a lot about amines, isn't it? Identify the compound X in the following reaction sequence. Okay, what is the reaction? C6H5 CH double bond CH2 with one equivalent of HBr, that is giving us X, and X plus NaOCH3 excess, that is giving us Y, and Y plus hydrogen palladium carbon, that is giving us Z. So which is, we have to find Z. Mistake. So we have to find Z from this reaction. So first thing first, what will happen if I'm adding HBr of one equivalent to this compound? Styrene. So which will give you, if it will follow Markovnikov's rule, rich is getting richer. So it will just apply to form C6H5 CHBr CH3, correct? With excess of NaOCH3, it will undergo nucleophilic substitution SN2, isn't it? Where the methoxide ion displaces bromine. So which will form C6H5 CHOCH3 CH3. Then hydrogen with palladium, it's reduction, right? Catalytic hydrogenation. So which makes, in this case there is no groups to reduce, but here we have the methoxy ether which is stable under this condition, so which will not do any reduction, so it will stay as it is. Which of the following reaction represents the reduction reaction? So sodium hydroxide with HCl, is it a reduction? No. What about calcium carbonate and FeCl3 with tin chloride? You can easily solve this type of questions by seeing the options. So the following compounds can act as both oxidizing and reducing agent. We very well know a compound that can act as an oxidizing and reducing agent both means it have to have a varying oxidation state. In this case, here I am having H2O2 is the compound which can act. Like if that is oxidizing means it can form H2O, and then reducing means it can form O2 and H+. So peroxide is our answer. The product formed when acetone reacts with Grignard reagent followed by hydrolysis. Simplest reaction. So what that will form? Which will give you alcohol, right? What type of alcohol this is? This is an tertiary alcohol. Let's move on to integer type questions. The first question is, a saturated solution of magnesium hydroxide has a pH of 10. Okay. So they're asking for the solubility product KSP for magnesium hydroxide. So magnesium hydroxide having the pH of 10. So what would be the pOH? That means that is 4, isn't it? So which means OH minus concentration, that is 10 to the power minus 4 molar. Okay. So usually the solubility product problem, what will I take? Solubility as yes. Right. So let's take the magnesium ion solubility as yes, and then OH minus ion as 2s because there are two OH minus ions. So in this case, we already found OH minus ion concentration, that is 10 to the power minus 4. So which means S is equal to 10 to the power minus 4 divided by 2, that is 5 into 10 to the power minus 5. Right? So which is nothing but magnesium ion solubility. Yes. So Ksp, which is equal to concentration of magnesium ion and then OH minus to the power square 2. So here I'm just going to substitute the values into 10 to the power minus 4 2 whole. I'll get 0.5 into 10 to the power 8 plus 5 into 10 to the power minus 13. So in the question they were asking for 10 to the power 13. So answer to this question is 5. Let's see the next question. Assuming the complete ionization of pH is 0.004 molar of H2SO4 is 10 to the power minus 1. Okay. So we know the concentration of H2SO4. So from that we can easily calculate the pH. Right? So I'm just going to put all those things in the formula. So here point to be noted is minus log of H plus ion concentration. I'm having 2 H2, so 0.004 into 2, which makes it 0.008, isn't it? So which gives minus log 8, that is 2.097. So if I am doing it to 10 to the power minus 1, which becomes 20.97 into 10 to the power minus 1, that is 21 as our answer. Let's say this question in the titration of 20 ml of 0.1 molar oxalic acid solution with 0.1 molar of KMnO4 solution in acidic medium. The volume of KMnO4 required for the complete reaction in ml they are asking. Okay, so in acidic medium what happens? The balanced reaction is also important. Why they are mentioning as an acidic medium? Because there are two type of reactions for KMnO4. One is acidic medium, another one is in basic medium. Correct. So here you can see the oxalic acid is reacting with KMnO4 in the presence of acid to give MnSO4, K2SO4 and CO2 and water. Correct. So here they are dealing with oxalic acid and KMnO4. Look closely. Once the reaction is balanced, you can see 2 moles of KMnO4 is required to react with 5 moles of oxalic acid. Correct? So which in the case, here they have took 20 ml of oxalic acid. So 20 ml of 0.1 molar oxalic acid, which means how many moles? So the N becomes 20 into 0.1. That is 20 ml. So 0.020 liters into 0.1 molar, which makes it 0.002 moles in form of oxalic acid. Here, in case of KMnO4, it is 2 moles per 5 moles. So how many moles per 0.00 moles? To the unitary method. So X, this is 0.002. So which will give you the answer? 2 into 0.002 divided by 5, which will be 8 moles. Now we have to find it in volume. So this much volume, this much moles, which is equal to how many? Volume. So volume of KMnO4, that is 0.0008 divided by concentration, molarity they have given, that is 0.1. So which makes it 0.008 liters, but they are asking it in ml, so into 1000. So the answer to this question is 8 ml. Let's move on to the next question, simple question. The number of structural isomers possible for the molecular formula C4H9Br. So it clearly refers that it is an alkane. So there is no unsaturation. C4 Br 1, 2, 3, 4, or else you can substitute it in the second place, 2-bromo butane also, or else you can substitute the methyl group in another position, 1, 2, 3, 2 methyl 1-bromo butane propane, and then you can write it like this, 1, 2, 3, 4. So this is a tertiary bromo compound. So total it can make 4 structural isomers. Let's see this question, last question. When 2-bromopentane reacts with alcoholic KOH. So alcoholic KOH means elimination. 80% of the product mixture is digestive product. That is our major product, which makes it more substituted as a major one. If 15.1 gram of 2-bromopentane is completely reacted, calculate the mass of digestive product formed. Okay, so they have mentioned 80% is our yield, and here we have 15.1 gram of 2-bromopentane. So find the number of moles of 2-bromopentane, that is given mass by molecular mass. So 15.1, the molecular mass is given, that is 151, which makes it 0.1 mole. Okay, as a next step, 80% is the yield. So from 0.1 mole, 80% is our yield. So how many moles must have been formed? 80 by 100. So which makes it 0.08 mole is formed. Out of 0.1 mole, 0.08 moles are formed. So what is the mass of the exact product they are asking? So mass, which is equal to, once again do the calculation, so 0.8 into molar mass of sides of product, that is 70. So which makes 5.6 grams as your answer. So to round off, you can make it as 6 as your single value answer. Okay, so we have solved these problems within 45 minutes. Hope you can solve it too. So keep solving problems. Whoever wants the mock test series to be continued, give me a thumbs up, give me a comment, or let me know in any way. Okay? Please prepare, start solving the problems. Thank you.